Welcome back to the nightclub. Lesson 9-6. More polar coordinates and rectangular coordinates. This time we're gonna.
Feature in the next video.
Can you get a feature?
Yeah, like I want you know how it says like on music videos, like by Taylor Swift.
Featuring.
Yeah,
Featuring Katie Beach. What would you sing?
I could like sing a song or like do you a math problem or something good.
She can't sing though.
She can't sing.
We talked about
Hey,
it. We have a law.
There has been plenty of hit
We have a
songs
law.
sung by people who couldn't sing.
We have a
Exactly.
law.
How
Yeah,
many
but I
people
don't
in this
think
world have zero talent?
We have a
Sorry,
law.
B.
I don't think we could take it.
I don't have any more.
All right. So today we're gonna go back a little ways, just a little. We have an equation here for our first example, and it simply says solve. What do you think you're solving for? X and Y. Okay. Now we're gonna make two equations here. We're gonna make a system. Okay. I told you yesterday, reals go together and imaginaries go together, right? So on the left side, what would be the real part? What's the real part on the left side? 2x plus y. I know that because it doesn't have a what? It doesn't have an I. So I'm going to write 2x plus y equals, on the right side, what's your real part? 9. Because there's no I.
So you just, so you're pretty much taking all the odds. Okay.
Okay? Now for the imaginary part. Okay? Again, I'm going to start over here on the right because they have the x and the y. See how it's xi, yi? So over here, that's going to be x plus y. Notice, did I put the i's? No, because I don't really care about the i's. I just want to know that that's the imaginary part. Okay? Equals, what part is imaginary on the left side? 3. And now it's just a good old-fashioned system of equations that you got to solve. Okay? We can make, which one you want to get rid of? The y. Okay? I'm going to do that by just making all of these opposite of whatever they are. Okay? Multiply everything by -1. And we get, that would be x. The y's cancel. Equals what? 6. And then I use that and plug it into one of my problems to get the y. So I'm just going to do that top one. 2 times 6 plus y equals 9. What is 2 times 6? 12. So I subtract 12 from both sides. And y equals -3.
Oh, this is like.
X is 6. Y is -3.
Oh, wow.
Why'd you put a negative by the x?
Here, I changed all the signs on the second equation, so when I added them up, the y's would cancel.
Oh, okay. So
I multiplied the whole thing by -1. It was x plus y equals 3. I changed it to -x minus y equals -3. Okay? Everybody good there? Easy enough? More easy stuff. Oops. Oh no. Oh no. Oh no. Okay. I just want it to be able to do that. Can I? There we go. No, I don't want to do that. Okay. I just want to move it up. There we go. Graphing. We're going to graph and find the absolute value. Now, we have done rectangular coordinate planes, right? They have x and y. Okay? We have done polar coordinates. That has r and theta. We are about to do a complex coordinate plane. Okay? A complex coordinate plane has a real and an imaginary part. Okay? So like what we usually call our x, that's going to be the real numbers. Okay? So that's the real. I's, the imaginaries, are what we usually call the y-axis. Okay? And to graph 3 plus 2i, you treat it just like it would be a point. Okay? How far do I go on the real axis? What part's real? 3. And then I would go up 2 on the imaginary axis. So I go over 1, 2, 3, up 1, 2. It's that easy. That is 3 plus 2 I, right there. That point. Okay? It also says find the absolute value. Okay? We do a poor job as math teachers, especially when you're younger, of explaining absolute value. Okay? Absolute value is not you just make whatever positive. Okay? What is the actual definition of absolute value?
Distance from zero.
The distance away from zero. So to find the absolute value of this complex number, we got to figure out how far is it from here to zero. Okay? I can make what kind of triangle there? A right triangle, and use the what? Pythagorean theorem. Okay? So when I do that, let me scroll up a little bit. This side is what? 3. This side is 2. And so basically the absolute value of 3 plus 2i is just the square root of 3 squared plus 2 squared. So what does that equal? 3 squared is 9. 2 squared is 4. 9 plus 4 is square root of 13. That's all you have to do to find the absolute value of it. Okay? Just like we talked about yesterday, you can put that in your calculator. If you put the absolute value of 3 plus 2i in your calculator, it's not going to tell you square root of 13, but it will give you the same decimal that is square root of 13. Okay? It'll give you the answer. Part B. How far do I go on the real axis? 0. And how far do I go on the imaginary? 4. Up or down? Up. What kind of 4? It's positive. So I just go up. 1, 2, 3, 4. Okay? There you go. There's 4i. What is the absolute value of 4i? What's the absolute value of 4i? 4. Now, why didn't I have to do the Pythagorean theorem on that?
Because straight lines.
It's just straight. I can count. 1, 2, 3, 4 gets me to 0. Okay? So, if it's just an imaginary number, you just take whatever the number is. Okay? Had it been negative 4i, what would my absolute value have been? It still would have been 4. Okay? It's just like you have always done it if there's just an imaginary or just a real. But if they have them together, you got to use your Pythagorean theorem. Okay?
Will we ever have just a real?
Yeah, possibly. I don't know. I don't know if these specific problems on your homework you'll have one, but yeah, I mean, totally possible. All right. Example 3, or excuse me, we're skipping example 3. I'm sorry.
We're graphing on this homework.
Just that graph, like not bad graphs, just a point. Oops, went too far. Sorry. All right. Express in polar form. We have expressed rectangular, okay, numbers in polar form, okay? But this is a different animal because these are complex numbers, okay? The ones we were doing were just like 4, 7, 5, 8, okay? These are a little different. So here is the polar form of a complex number, okay? So you're going to take, and I'm on page, what page is this? This is on page 588, if you want to follow along, but I'm writing it up here. It will be r times the cosine of theta plus I times the sine of theta. That is the polar way to write complex numbers. Okay?
Why is it called polar?
I'm not really sure. I guess because it looks like, if you look at it, you remember our graphs yesterday?
Yeah.
If you look at that, you ever seen like a globe? Have you ever seen the top?
Yeah.
At the North Pole or the South Pole?
Yeah.
It looks like one of those coordinate planes. Does that make sense?
Mm-hmm.
So I guess that's why they call it polar. I'm not really sure.
That was very specific for not being sure.
It just makes sense to me. Like I said, I've never been told that.
We'll go.
I would
with it.
assume.
His guess.
We'll go with it.
I assume.
We'll go.
Okay. See, there's this whole other math that y'all really haven't gotten into yet. You learned geometry from Coach Glover, and he did an awesome job teaching everything. But that was Euclidean geometry, and in Euclidean geometry, parallel lines don't intersect. You know what I'm saying? You can only, if two lines do intersect, they only intersect in one point. Okay, but if you change that to what's called spherical geometry, all that gets turned upside down, kind of. And what I mean is, if you're talking about a globe, okay, what are these lines that go long ways? Longitude, the ones that go this way are latitude, and we call them lines, right? And where do they all meet? At the North Pole and at the South Pole. So that just breaks in one rule of geometry that you learn. Two lines only intersect in how many points? One, right? Well, they intersect twice. Okay? So just little things like that. So there's they got a different set of rules when you're talking about 3D rather than just 2D. Does that make sense? It's Caden's fault. All right. He asked why they call it polar. And I just went on a tangent. Do your little I just went on the tangent. It was awesome. Okay. Polar form. So please understand, you're doing the same thing you did the other day. You're just putting it like this. You're adding a cosine and a sine with it. Okay? So to get R, what am I going to do with these?
You're going to do negative cosine.
Not yet. I got to get R. How did I get R the other day when I was doing X and Y?
X squared.
Square root of X squared plus Y squared, right? It's the same thing.
Square root of -3 squared.
-3 squared plus 4 squared. You don't have to include the I. Okay? You just have to include the number that's in front of the I. What would R be? Y'all should know this. It's 3, 4, 5. Okay? 3, 4, 5 triangle. 9 plus 16 is 25. Square root.
I'm not good at
Square root
squares.
of 25 is 5.
That's what I'm saying. This is a triangle you should know. If it's 3, 4, 5, that's a right triangle. That's one of those special Pythagorean triples that you kind of
So you
just need to know. Okay?
So is theta just still y over x to me?
Theta is the inverse tan of y, which would be what in our problem? 4 over x is -3. Put that in your calculator. They put it in radians. We'll just do degrees, okay? I don't think it matters. So what do you get when you do the inverse tangent of 4 over -3? I got -53.1. Would I want to keep my answer like that? No, I need to add what?
360.
Add 360 to it. That would be 306.9.
So now we just write out the form.
Hold on, wait. I've messed up, I believe. I added the wrong number. I'm sorry.
What do you mean?
What quadrant? You got to think in your head. I did. I failed as a math teacher. I apologize.
Oh, they're all positive. And
No. Just wait. What quadrant is this angle in? Fourth quadrant. My point is in what quadrant? Second quadrant. I'm going left. Well, whoa, what'd I do?
Oh, okay.
I went left
Yeah.
and then I went up, right?
Yeah.
Left and up puts me over here.
Yeah.
So I didn't need to add 360 to that. What did I need to add? 180. That'll get me in the right
So you
quadrant.
want them both in the same quadrant.
Correct.
Okay, so if it's
Your angle should match up
so if
with
you
your
have-
point.
Okay, so if you have
Okay.
180, then that makes it what?
You add 180, yeah, that makes it different. So, oh, that's wrong. $126.9.
So we have to figure out whether we need to add 90, 180, 360.
Correct.
And we
Okay.
make the degree match the point.
Now, I'm going to give you a little kind of guide here. You can do this two ways. All right? You can either do it like we just did and figure out what quadrant it's in. All right? Or, everybody listen real close. If your x is negative, you're going to add 180. That's really all you got to remember. If your x is negative, you're going to add 180. Okay?
Positive, you have 1.
If it's positive, you add 360.
Cool.
Easy enough to remember? Okay? Or like I said, you can just use common sense. Say
Make
common and make them match. Okay? So, we're not done yet though, because we haven't wrote it in polar form. So our final answer, we're going to say, all right, what's R? 5 times the cosine of what is theta?
126.9.
Plus I sine of 126.
I only goes with the sun.
Only goes with the sine. That is your polar form of the complex number. Okay?
What? If it doesn't.
Part B, to get R, we want to say the square root of what squared plus what squared?
1 plus
1 squared plus the square root of 3 squared. So that's square root of 1 plus 3. What is the square root of 1 plus 3?
Why'd you do it like that? Oh, because it's just.
2. Square root of 3 squared cancels the square root off, right? Okay? So R is 2. My theta will be the inverse tangent of square root of 3 over 1. I think that one's on my chart, but you can still put it in your calculator and figure out what you get. Inverse tangent of square root of 3, basically. 60. Does my angle match up with my point? 1 square root of 3 would be in what quadrant? First, I go right and up, and 60's in the first quadrant, so they match up, so we're good. So 2, I don't know why I put R, sorry. 2 times the cosine of 60 degrees plus I times the sine of 60 degrees. All there is to it. Okay? You are literally taking the same thing you did a couple days ago and adding the cosine and the sine with it. That's the only difference. Okay? No, we got one more example. And then I'll leave you to it. And if you, I know I say the evens up there, but I think we're going to do the odds because I want y'all to be able to check them. All right. Sorry, Chum. All right. All right, y'all can do the even. No. We all got to do the odds.
Only did one.
All right, express in rectangular form. So now we're just doing the other way around. Okay? Nothing's new here. This is much easier, believe it or not. Okay? You literally, all you have to do is distribute. Okay? So, this would be...
Can I write that down?
Sure. No, nobody's stopping. Go right ahead. All right. That's going to be 4, what? Cosine of 11 pi over 6 plus 4i sine of 11 pi over 6. What is my angle in?
Radians.
Radians. So, you can make sure your calculator is in radians, or 11 pi over 6, I believe, is on your chart that you can refer to. Okay? 11 pi over 6 is the same as 330 degrees. So, I'm going to look at my chart. I see your chart here. Okay. Find the cosine of 11 pi over 6. And it tells you that it is square root of 3 over 2. Everybody see where I'm getting at? Okay. Everybody good? Sine of 11 pi over 6 is what? Negative 1/2. And then you just simplify. Okay? What is 4 divided by 2? 2 times the what? So we have 2 square root of 3. What is 4 times negative 1/2? Negative 2, but what? I. Minus 2I. That's it. Okay? Y'all have a great day. Stay above the line. See you next time.